How's it going, everyone? Let's just talk about the elephant in the room first. It is 7:15 p.m. on a Tuesday night in Vegas, and you have all chosen to be here with us to talk about machine learning and open source software. That makes us all friends immediately. You can't do anything about it. Congratulations, I'm your friend now. So, welcome to ML with Metaflow and Kubernetes, prototype to production on Amazon EKS. As I'm sure the title can make you realize, this is kind of a two-part talk. We're going to be talking a little bit about AI and ML ops with open source software and a little bit about Kubernetes. We'll try and contextualize both as best we can. My name is Rob Hilton. I'm a principal solutions architect with AWS. My good friend Roman, who will be introducing himself shortly, is a senior software engineer with Netflix's ML infrastructure and platform teams. And as I'm sure you probably know, Netflix has been a longtime customer and partner of AWS and is also a big open source proponent. And they have teams that have focused on applying that lens for the last 5 to 10 years to data science and data scientists' business problems. Now, this talk in particular has a special place in my heart. Roman knows this as well. It was 2 years ago, in 2019, right here at reInvent, that Metaflow was initially open source to the world. I'm not going to steal too much of Roman's thunder talking about what Metaflow is and what it does, but I will say if you're interested in this little piece of history, please feel free to go back. More Data Science with Less Engineering is the name of the talk. You can find it on YouTube, on our official reInvent channels. Please go watch it. It's been a wild and crazy journey over the course of the last 2 years with new features and some awesome adoption metrics that Roman will be able to tell you about. There are going to be a couple of things that we do in this talk. We're going to talk about Metaflow, where it's come from, what it's been up to the last few years, and then I'm going to spend a little bit of time toward the end talking about one of the newer feature releases that was merged into the SDK not long ago, about its support for Kubernetes and how joining those two worlds together has some unique and interesting characteristics, but also some challenges that you, as my fellow community and friends, can help us solve for. With that, I'd love to introduce Roman. He can come up and tell us some stories about Metaflow.
Thanks, Rob. And yes, thanks so much for coming out at 7:15. Oh, it's bright up here. All right, so as Rob mentioned, my name is Roman. I've been at Netflix for 2.5 years, roughly. I was here in 2019 as well when we open sourced Metaflow. But I'll describe Metaflow as actually been a project that's been going on for a little bit longer, even before I joined Netflix. And at Netflix, I still basically work on Metaflow and continue developing it. So, Metaflow. What is Metaflow? So if you go on the documentation for Metaflow at this URL here, you'll see that it says that Metaflow is a human-friendly Python library that helps scientists and engineers build and manage real-life data science projects. So basically, in short, Metaflow aims to help data scientists do just data science and not have to worry about all the fun part that I like to do, which is the infrastructure part of a real-life data science project. So if we look at what a real-life data science project is and what the parts are for that project, there's several parts. The first one is the data, the ETL pipelines, finding your data, feeding it to your model, actually doing something with it, and then potentially producing your model as data to be consumed later, for example, for inference. Then compute, as most of you probably know, your friendly laptop is usually not enough to train these models. You might need bigger machines, more machines. You might need something like AWS. Orchestration. Typically, you'll want to retrain and deploy your model periodically, either just on a schedule or when data becomes available as a previous pipeline has produced the data that you want to use to train your model. Monitoring. You'll want to know whether the pipeline that you have set up is actually running and if it's running well. You might also want to know about the quality of your model, possibly as well whether or not the data has drifted from when you trained. So you want to monitor all this stuff. Prototyping, you usually want to basically be able to try out new models quickly, see how they perform before you deploy them. You might want to do A/B testing, things like that. And then the actual part that data scientists are typically interested in, which is the actual model development part. So we'll go, next few slides, I'll go over some of these parts, describe them, and then show you how Metaflow can help with each of these sections. So for the data part, one tool that's pretty obvious is Amazon S3, which I'm sure you've used before. So if you have S3, you can store a bunch of stuff in S3. You can store Iceberg tables. You can store Parquet files. At Netflix, you might imagine we have a bunch of movies, or at least metadata about movies as well, that you can also store in S3. And you have also other tools that may feed into S3. You can have Presto and Spark that basically process some other data that might be in S3 or somewhere else, and then dump it back into S3, for example. And then you might have systems, and these are names that we use within Netflix. You might have systems that actually allow you to index this data or find it or just reference to it. We have something called Metacat, for example, at Netflix. And then finally, your machine learning model itself, or the workload that you have, will basically use all this data that it has. Potentially you create or have new queries, and then dumps things back into S3. For example, the model, you might write it back out to S3. So then if we move to the compute side, so typical ML workloads, you can divide them up into different steps. And I've already mentioned some of these before. You'll have potentially your fetch the data, you do some pre-processing for it, you do some feature extraction, you do some hyperparameter search, et cetera, et cetera. So if you kind of like model your ML workload in a bunch of tasks that you have to execute potentially sequentially or with some sort of order, you can put them in a task queue, and then you can use something like AWS Batch that allows you to execute them on EC2 instances or on Fargate instances, et cetera. So Batch is great to do this, and I'll show you how Metaflow allows you to do this easily. Considerations with compute is, cost efficiency. You want to balance the cost with the execution time. You potentially don't want all these tasks to execute on the same type of resources. Potentially, some tasks may need a GPU resource. Some tasks just need a lot of memory. Some tasks need a bunch of CPUs. You don't necessarily want to have all your tasks execute on the same type of machine, because that would be very inefficient, both in terms of cost as well in terms of resources just generally. And we all care about the planet, or most of us do. Anyway, next, orchestration. So there's a very nice tool in AWS called Step Functions, which kind of allows you to transform this task graph of sort that I've mentioned in the previous step, where you kind of divide the steps of your computation into little tasks, into a graph that you can then have AWS Step Functions execute. And you can also trigger the execution of that flow, with EventBridge, so you can link together multiple flows. So you can have your ETL flow that produces some data, and then that would trigger, for example, this training flow that can trigger some other stuff downstream. Then for prototyping, lots of data scientists love notebooks. There's SageMaker on AWS, or just vanilla Jupyter notebooks as well. It's really easy to prototype in a notebook. It's pure Python, so it makes it really easy to develop. At least data scientists are very familiar with Python. And then hopefully, the idea is that if you develop something in a notebook, you would be able to quickly move it to production. And I'll show you again how Metaflow allows you to do this seamlessly. And monitoring, we actually have a Metaflow UI. And like I said, monitoring is basically monitoring both the execution of your flow that you're executing, as well as potentially details of what's happening inside your training and details about your model. Metaflow UI mostly focuses on the first part. It shows you basically what's executing, how it's executing, et cetera. And you can kind of see. I'll go into a little bit more detail about Metaflow UI in a couple of slides. And the model development, I'm not going to go into it here, but basically model development is actually writing your code. So if we look at this here, this stack where you have all these different tools that you can use for all this part, data scientists really just mostly care about the top two. The data and how that's done, the compute, the orchestration, monitoring. They just want it to just work, ideally. They don't want to have to worry about it. This might be reductive somewhat, but most data scientists that I've talked to anyway really just want to focus on what they do best, and which is data science. And from a business point of view, it also makes sense to pay the data scientists to do what they do best, as opposed to having to focus on some stuff that they're potentially not necessarily optimal at doing. So we have all this stack. So Metaflow, what it does, it takes all this and puts it in a nice little bow, or package with a nice little bow on top, that basically kind of abstracts away the bottom part and gives you freedom in the top part to kind of do whatever you want. In the next couple of slides, I'll show you how that actually happens. So Metaflow, the basic concept, and this is not a talk necessarily about all the features of Metaflow. I'll go quickly over some of the concepts, and hopefully it gives you enough information that you can go and look on the documentation website or come ask me questions later about more details. But the basic concept of Metaflow is that it models your computation as this directed acyclic graph, where this is a simple representation of, so you have like a start step. After the start step executes, then you have the A and B step that can execute in parallel. And then once both of them are done, you can have a join step that can consume the inputs from A and B, and then you'll have an end step. Metaflow supports this type of simple graph. It also supports something called for each, where you can kind of have like a variable number of parallel tasks that are running in parallel based on, for example, like you want to do a hyperparameter search, or you want different parameters for all your searches. It's a directed acyclic graph, so there's no loop in Metaflow, and Metaflow will basically take care of kind of passing data along for you. So if you produce some data in the start step, you'll be able to access it in the A step and in the B step. Same thing in the join step, you'll be able to see what A produced or has, what B produced or has, and kind of propagate your data down. And this is really easy to do with Metaflow. All you have to do is basically take a Python file, and you just annotate it with these little step decorators, and just say this is a step. And that's it. From Metaflow's point of view, that's all you need to do to actually code up a flow in Metaflow. Inside each of the steps, you can basically use whatever code you want. Metaflow has absolutely no opinion about the code that you use inside it. So if you want to use TensorFlow, great, use TensorFlow. If you're a PyTorch fan, you can use PyTorch. If you want to use any of the other libraries that are available to you in Python, have at it. There's no restriction at all. So in that stack that we were discussing earlier, the prototyping and the model development part that data scientists care about, Metaflow basically doesn't really care about it, in the sense that it allows the data scientists to do whatever they want at that level. It's not at all opinionated there. So this part here is not yet an open source, but will be hopefully in the next couple of months. We're working on open sourcing it now. Metaflow has ways to allow you to access data from S3 in a high efficiency manner with minimal copies. So it tries to basically, it will do parallel downloads, and then it'll read your file, and it'll try to avoid conversions if it can of your data. So we have this notion called Metaflow data frame that you can, for example, read directly from Parquet, and it'll make that available to you in a very efficient manner. So again, this is not an open source yet, but I just wanted to mention it from the data point of view. Metaflow itself, like I mentioned earlier, does handle your data, like passing the data through, and it will persist it in S3. But we also have this high efficiency S3 downloader, which hopefully will be available in the next couple of months. And then if we keep going up the stack, you remember the compute aspect of things. So here, for example, we want 16 CPUs for your A step, and then we want 20 gigabytes of memory for your B step. And we want to execute these steps on machines that have these types of resources. Well, in Metaflow, it's really simple. You basically add another decorator, in this case, batch. There's other ones for Kubernetes, for example, and internally at Netflix, we use something called Titus. But the concept is the same, where effectively you just specify the resources that you want, and Metaflow will go ahead and schedule that step on a machine that has these resources, of course, if the machine is available. But so here you see that I annotated the A step with a batch CPU equals 16, and I annotated the B step with a memory equals 20,000 to indicate 20 gigs of RAM. So really easy. And here you see again that it is concerned about trying to make it optimal in the sense that you won't get the same machines for both, and the user can specify what they want. You can also specify, for example, if you want a GPU machine, so you can say GPU equals 1 or GPU equals 2, for example. Step functions, there's two very simple commands that allow us to take this Metaflow graph and convert it into a step functions graph, effectively, and deploy it to step functions. So there's this a create first, where basically it will take your graph, convert it, upload the code, do whatever it needs to do to make step functions understand how to execute it. And then you have another called trigger, which basically tells step functions, okay, now you can run an instance of this flow. So for the orchestration side of things. Introspection, so basically kind of figuring out what you want to do. We do have the UI as I mentioned, but Metaflow also provides a very easy to use Python client, which allows you to kind of access everything that you have run in the past. So here, for example, we say, hey, I want my latest run for MyFlow. Let's assume this is called MyFlow, a very innovative name. And then you can say, okay, well, did step A succeed? So if, if it's successful, and this is not pseudocode, this is actual code that you would write if you were using Metaflow to do this, then you can basically print the data that you produced in step A. So for example, if you produce something called X, you could just print X. It would fetch it for you from S3, deserialize it, and just print it here. And if it's not successful, you can also grab the log, the standard error here, so you can kind of see what happened in your run. So again, this is actual code. This is as simple as it gets. Metaflow basically behind the scene, when it's executing, will have stored all your, we call them artifacts, so the data that you produced and stored. It will have also stored the execution log, so the standard error and standard out, and we'll have persisted all of that into S3, and the client basically just looks that information up and gives it back to you. And behind the scene, a lot of the UI actually does this as well to kind of like get the data, things like that. So, Metaflow history. As I mentioned, Metaflow actually started a while back at Netflix. So if we look at a timeline, it actually started in 2017. I wasn't at Netflix back then, but a couple of people that were on my team were and started it as a way to basically help data scientists at Netflix produce better business results. At Netflix, kind of a bit of a history and context here, there were historically two sides that used machine learning. There was the recommendation side that used machine learning, which you might be aware of, which is what, if you have Netflix, hopefully everyone here does. Yeah, I have to do some advertisement. Anyway, if you have Netflix and you log on to Netflix, the row that you see, the titles that you see, the order in which you see them, the title art that you see, all that is part of the recommendation system, and basically comes out of a historically different stack than Metaflow, which tries to recommend to you what they think you would like to watch next and try to attract you to different titles. But there's a whole other side of Netflix that basically wanted to use machine learning, which wanted to gain insights into what types of movies to produce, how much budget to allocate to movies, what types of scripts resonate with people, and things like that. And so that side of things was not effectively a recommendation system. So the other system was mostly a recommendation system, and they were targeting, basically making optimal recommenders. But a whole other slew of Netflix wanted to use data science for other purposes. Like I mentioned, the titles. There's also infrastructure also wanted to use ML, for example, to figure out where to place the titles on the Open Connect network to minimize latency and things like that. So there's a lot of other use cases in ML, and there was no real infrastructure for these people to use, and it was kind of a bespoke way of actually trying to deploy your model. So in 2017, the founders of the team that I'm on started Metaflow. Since then, it's actually been fairly popular. There's been over 300 unique flows, so these are the types of flows, so like the machine learning models. This doesn't mean that they weren't tweaked or anything, it just means like that's just the 300 different names that might have been tweaked over time. 150 plus users, which is fairly high. Netflix is actually a small company. There's only 5,000 engineers, or if there were, I think, still. So of those, even fewer data scientists, and of those, 150 of them have used it. There's 1.6 million runs, so 1.6 execution of Metaflow that have gone on, and it's been growing pretty quickly. I think I checked, pretty much half of these runs have occurred in the last year or so it's kind of accelerating. In 2019, as Rob mentioned, we released Metaflow as an open source product at AWS reInvent, so in Vegas as well. In 2020, we integrated step functions, so the initial release didn't have the step functions integration. Since then, you can kind of see that it's a fairly popular project. This is the star count, so this ends in October 2021 because that's when I had to do these slides. But I checked yesterday, the star count is now above 5,000, and GitHub unhelpfully just says 5,000 plus. So it keeps going up, so fairly popular project in open source. In 2021, it's actually seen a lot more development. and I wanted to focus on this a little bit. So in January, we released Fargate integration, so you can actually use batch with Fargate as opposed to just with EC2 instances if you don't want to manage your EC2 fleet. In March, something interesting happened. So remember I mentioned that colleagues of mine had started Metaflow in 2017? Well, said colleagues decided that they wanted to take Metaflow a little further and decided to form a company called Outer Bounds to basically promote and develop the use of Metaflow in the open source world. And hopefully, I guess, make money out of it somehow. So anyway, a couple of my colleagues went there and started Outer Bounds and are continuing to develop Metaflow, and we're collaborating with them to basically continue to bring you features and hopefully benefit from all the stuff that you hopefully will do with Metaflow. In May, we released a project decorator. A project decorator basically allows you to kind of silo your flows, so you can basically have multiple of them talk to each other in a way that kind of like branches and production and staging, stuff like that, so you can kind of keep them separate and have one flow that you're developing, not mess up your production flows. This is still kind of an alpha. Well, the project decorator is released, but the usefulness of it in open source is still a little not as useful as it is internally, where we do have a way of triggering different step functions one after the other. The trigger is coming in the open source world as well. This whole, in August, sorry, before the other part, in August, a Slack bot called the Metaflow bot was released by Outer Bounds. It was a revamp of an internal version that we had within Netflix that wasn't working anymore. And this kind of allows you to kind of query what's going on. You can kind of see what flows are running. You can ask it to show you the data and things like that. This version of the bot is read-only, so you can't launch anything with it. But you know, it's quite useful if you have Slack in your company. And then in October, we released a fairly big release of Metaflow 2.4.0, and this capped off kind of this whole effort that had started at the beginning of the year, actually slightly earlier, but more intensely at the beginning of this year, to kind of re-merge the two versions of Metaflow that we had. So when we released in 2019, for efficiency reasons, we basically forked off of the version that we had internally at Netflix. We stripped out a bunch of stuff that were internal only to Netflix and that didn't have an open source equivalent. And we added things like batch, step functions a little later, et cetera, to make it more palatable to the open source community and more useful. And it took 2 whole years to actually bring those versions back together. So yeah, never fork if you ever intend to bring them back together. It's very painful. And so that's why the project decorator came out, and there's a couple of other things that I don't mention here, but so now at this point, the version that we use internally at Netflix and the version that is available in open source is the same version, which will hopefully allow us to release more stuff that we develop internally and also take back stuff that is developed in open source. In October as well, Kubernetes support came online, and Rob will talk about that in the second part of this talk. And then in October as well, we released Metaflow UI. And I will talk about that in a few slides. So if you notice, October was a busy month. And no, it was not due to reInvent being in November. This is just when things happen to be ready. But hopefully more stuff will continue coming out, and I'll give you a preview of some of the things that we're working on right now. Just a quick shout out to some of the users, and a lot of these articles have been published completely unsolicited. We learned about them because we read the blogs, or I think Savin, one of the original developers, has alerts on some of the terms on Twitter or on Medium. And so anyway, so just wanted to share, the Swiss knife tool in data science. This was written, and then MLOps without much ops, also something on how Metaflow makes it easy to do MLOps without having to deal with a lot of the infrastructure, which was exactly the point that we were going with here. Improving data science processes to speed innovation, at Realtor.com. Maybe they also do renovations, I don't know. But this is another company that uses Metaflow, the open source version. And then, no, this is not convolutional neural network, but the actual news website. Accelerating ML within CNN. Was another article that showcased how they use Metaflow to accelerate their production flows. So you can check out some of these articles if you Google them on Medium. You'll find them. Other companies have also started integrating with Metaflow, Weights and Biases, Dolt, and Selden. I'll just give a brief description of what Selden does. But these other integrations were developed by these companies, and you can find them online as well if you look for Weight and Biases Metaflow or Dolt and Metaflow. You'll find examples in these companies' GitHubs usually about how to use Metaflow with their products. So for Selden, the idea was that you could basically use Metaflow to do the training part and have a step task at the end. So you remember, if you remember the DAG, kind of at the end of this, the training DAG, you'd have one that basically does the deployment using Selden. And then you can use Selden's client to do your inference. So train with Metaflow, deploy with Selden, use this Selden Python client using this little kind of code snippet that they have, and you effectively have a fully deployed model trained with Metaflow. Internally at Netflix, we do have another solution for deployment, but that one is not open source. So Selden's a great way to actually use Metaflow kind of end-to-end all the way to your inference side. If you go to that URL, you'll basically see the example that Selden put together for this and how it works. Just a brief description of the UI that we released. So again, this was released in October, has been fairly popular. Just wanted to kind of show you what it looks like a little bit. I'm not going to give a demo, not that courageous. But you can see here at the top, the little search bar allows you to search directly with a path spec for Metaflow tasks. So each task in Metaflow kind of has a path spec. There's like your flow name, run number, step name, and the task ID or something. That's given to you when you run it. It's also what the client uses. So you can just kind of copy paste it there to kind of navigate to it. You have easy filters on number 3 here. You can kind of sort using tags, for example, which are a pretty powerful feature that you can tag your workflows and then kind of group them together, or user, whether they're running, et cetera, et cetera. And then it gives you this view in 4, which is kind of a real-time view of what's happening in your system. This view does actually refresh, so if a new flow shows up, it will immediately appear at the top and show you that it's running. So that was one of the big focuses of this UI. We wanted to make it extremely responsive for users. So it is wicked fast, really. I mean, I'm pretty surprised that they managed to do this. We had contractors help us with this. And it's quite useful. So this is the main view, and then you have a timeline view where you can kind of see the execution of all your flows and how long everything took when they started. Then you can, I'm not showing the other slides, but you can kind of drill down and show also the artifacts, so what was produced, the logs, et cetera. So yeah, it's pretty useful. It's pretty nifty. It's also open source, so you can download it. There's instructions of how to get it running fairly quickly as well. And I think there's a CloudFormation template for this too. What we're working on next for Metaflow, just a couple of things. Model cards, this is something that I think started at Google, which would basically allow you to generate some sort of HTML report after the execution of one of your tasks. So you could, for example, just generate something about this is how long the execution took, this is how much memory it took, or you can generate something and introspect into your model that was produced, for example, and says, well, these are some of the metrics that this model has. So this will also integrate with the UI that I just showed you, so you'll be able to kind of see that output directly in the UI, or if you don't have a UI, you can just use it in a standalone manner. It'll just show up a browser, local browser, and just display this HTML page. AWS Lambda support should be coming ever so shortly. The PRs, I think, are there. They just haven't been merged. So this will allow you to run on AWS Lambda instead of AWS Batch. And lots of other things that we're working on, but not yet fully fleshed out. One of the ones that I can mention that has become fleshed out since I made this presentation is the ability to run a kind of a grouped manner. So you'll be able to kind of request multiple machines together for one of your steps and run them in parallel, as opposed to each step kind of runs on one machine. This will be useful if you want to do training, for example, with multiple GPUs. All right, and with this, I'll hand it over to Rob for Metaflow on Kubernetes.
All right, thank you, sir. Real quick, I do have an open question. It's not my imagination. They were singing Eye of the Tiger over there for like 30 minutes, right? Okay, good. Just making sure I wasn't slowly going crazy while I was listening to Roman talk. Awesome. So As Roman already mentioned, the Kubernetes support for Metaflow actually did drop in October. But I mean, that's the amazing thing about the open source community, right? Is the PRs get merged when they're done. But I don't think it's entirely fair that all the service teams and keynotes get all the announcement excitement. So I'm just gonna pretend we're announcing the Kubernetes support for Metaflow today, and maybe you guys can get excited too. This is either gonna be really hilarious or really amazing. So today I'm happy to announce that Kubernetes is gonna be supported on Metaflow. Yes, thank you, community. Thank you, thank you. So, not unlike Roman, I'm actually a bit of an infrastructure engineer myself. I'm only just good enough at data science to be dangerous, and the way I write code for it is horrifically bad. But there are a lot of parallels between the container orchestration ecosystem and the way AI/ML pipelines run. So what's interesting about this is that if we zoom out and we think about some of the themes that Roman talked about over the course of the last 30 minutes or so, Metaflow is really about segmentation and abstraction. I, as a Kubernetes, love all the stuff that goes on under the covers and love all the magic about the way it schedules against nodes, but realistically, Metaflow isn't for me. It's for the data scientists that are writing in Python or R. So at the end of the day, their goal is to use those little step decorators to define all their interlocking dependencies, to move data from point to point in that graph. And the nice thing about Metaflow is its focus is about abstraction. It's about disaggregating those individual runtimes, segmenting them, and allowing them to work independent of where they happen to live. So for data scientists that are prototyping, it's super easy to run a Metaflow flow on a laptop, and it works great as long as the data set can exist within memory and you're not overrunning things like virtual CPUs in memory and all that fun stuff. But the magic of Metaflow is that because of the way you write those graphs, all of those exact same steps can, for more or less with the flip of a switch, be translated over into containers or what's effectively batch operations that run on distributed compute systems like AWS. Another way to put this is, while it's not the only thing Metaflow does, one of the core tenets that Metaflow provides to something like data scientists or any operator is user experience. The ability to write your code and segment your applications without the need to care about that underlying infrastructure, no matter how much people like myself or Roman or maybe some of you in the room do care about that. So at the end of the day, another way to think about that, if we follow it to its logical conclusion, is that runtime doesn't matter. So in the original open sourcing of Metaflow, as Roman mentioned, the distributed compute system that AWS provided for Metaflow was AWS Batch. For those of you who have not used it, it's a fantastic way to run run-to-completion operations on containers using AWS API calls that land on ECS. It's a bit of a different paradigm than I think we're used to for most container orchestration systems that are used to daemonized or long-running stateless workflows like web applications. But it's a very relevant use case, and also one of the earliest ones that containers were designed for. We have a job to do, you can spin it up with all of its appropriate dependencies, and then you can be done with it and it goes away, and you don't have to worry about all the stuff you might have installed on your laptop or server or what have you. So at the end of the day, the question is, what do data scientists even care what the runtime is? And the answer is they probably don't. But supporting Kubernetes does something interesting, and that is that it helps you manage co-location of your pipelines and applications. So when we start supporting Kubernetes, or I mean when we're announcing Kubernetes today, all right, there's the hilarious one that I was looking for. I'll applaud myself. When we're announcing Kubernetes today, what it means is that we can now co-locate our data science pipelines and some of those orchestrated applications with the rest of our data ecosystem and the rest of our application ecosystem. Many of us, operations teams, infrastructure teams, and otherwise, have probably adopted Kubernetes in some way or another across the line, and having this disaggregated infrastructure set isn't super convenient. So the reality is Kubernetes as a runtime provides a much more open and abstracted way to manage our application dependencies and co-locate our Metaflow pipelines in more unique and interesting spaces. Now, I'm going to talk about what's cool about Kubernetes because I think it's relevant, because this, even though it's easy to say it doesn't matter, it wasn't without its challenges. There's a lot of thought exercise when we talk about adopting something new like Kubernetes, because unlike a managed service like AWS Batch, Kubernetes has a lot of open source bits and fiddly things that we have to take into account when we decide how prescriptive to be. So first of all, for the people in the room who are not Kubernauts, let's just give a brief description so that everybody can go home and understand. Kubernetes is a portable, extensible, open-source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. It has a large, rapidly growing ecosystem. Kubernetes services, support, and tools are widely available. Thank you. This has been my talk. Everybody gets it now, right? Anyway, all that aside, the definition is arbitrary. Kubernetes is yet another container orchestration system. But there is a key word in here that I want everyone to pay attention to, and that's the word declarative. That's potentially the thing that's unique and special about Kubernetes. And that's where it gets really, really interesting when we talk about systems like Metaflow, which are designed to run in order. First and foremost, what does declarative mean? This is something we've all probably read about at some time or another. There are lots of different languages out there that say they're declarative, and lots of different systems that say declarative is bad. You want to use something you're used to, like Python or whatever. But the reality is it's just two different ways to think about executing applications. So realistically, the alternative to declarative, the one we all probably think about when we think of Python or application development or sequential execution, is imperative. So imperative means you define the how. Like, there are a lot of things that are imperative. Programming languages are imperative. They work from top to bottom. AWS, in many ways, is imperative. You create your VPC, you create your security group, then you spin up your EC2 instances. If you want it to be scalable, you create your launch templates at that point, and then you create your auto-scaling groups with your launch templates, and then you create your load balancer if you want to do, like, ingress control. So that, in its own way, is imperative. You have to do those steps in order. Declarative is a little bit different. Declarative is about saying, my end state is a web application that's open to the internet. It's about saying that you want a cheeseburger and not that you want 2 pieces of bread with a warm piece of meat and a piece of cheese in between, and then hand me that thing that you just made. It's really just 2 different philosophies. And what's unique about Kubernetes is that it's one of the first infrastructure platform systems, and I'm going to say this carefully, that was designed and built from the ground up to operate in this way. Declarative development paradigms aren't new. They've been around for a long time. Kubernetes is far from the only one and far from the first, but I would go so far as to say it's unique in the fact that it was designed to be that way entirely from the ground up in the way you specify your requests to the API. So an example of that is that you have this blob of YAML, and it looks pretty benign when you glance at it, but there's some interesting stuff going on under the covers here. On the bottom, we have a deployment. That's a fancy way to say I need some compute running a specific container image. And on the top, you have some ports open that speak to that container image. Now, they do reference one another, but there's nothing explicit that says do this before this or this depends on this. This basically says just give me some compute and give me a way to talk to that compute. And rationally speaking, we actually see it in this YAML document defined in reverse of what we'd expect, because you can't open a service to something that doesn't exist. So this is a simple example of what a declarative API manifest could look like. These can be in different files. These can be in all sorts of random orders. Doesn't matter. It's Kubernetes' job to reconcile this request, turn it into whatever its magical little API objects are. Some of the most common are service, ingress, deployment. And then in turn, Kubernetes as a platform reaches out to things like AWS and does stuff like create our load balancers to allow that traffic to ingress. Or if we specialize something like a persistent volume, which is also a choice for Kubernetes, we can reach out to EBS and attach that to our containers automatically. It's Kubernetes' job to take this thing that you want, this YAML that you want, you've told me you want it, and just to make sure that you have it and it stays that way forever. That's what it wants to do. That's what it lives and breathes to do. And that's amazing for web applications that are online all the time, where that state doesn't change. It's a little more complicated when we're talking about something like Metaflow, which lives in a very imperative world, these big sequence dependencies. So there's some inherent challenges with this. Now, for those who are familiar with Kubernetes, Kubernetes does have an API. That API is called Batch, and it's the job API. It basically says, run this thing to completion and tell me how it went. And on paper, this fits our use case pretty well, right? All we have to do is submit a batch job. Everybody's happy. Kubernetes does what it's supposed to do, turns that batch job into a pod, which in turn turns that pod into one or many containers. Those containers run, and everything should be happy. It goes through this sequential process where those containers have statuses. In this case, we go through creating, running, completed. Hooray. We've run our batch operation, and that's all we need, right? Okay, maybe. But the practical reality is the vast majority of these data science flows do not look like this. The idea of something being finished or not finished doesn't make a whole lot of sense when you're talking about piping data through lots of sequential operations. Just having an on or off, running or not running toggle to define the state of our batch operations isn't helpful when your batch operations look like this. Where a failure here can have a cascading effect that runs all the way downstream and causes problems all the way down the end of the line. And if all you can see whenever you introspect this stuff is that a container is complete or not complete, it doesn't help you as a data scientist or operator understand what went wrong where. And this is where the magic of Roman and Outer Bounds and the Metaflow team come into play, because a data science SDK that understands the impacts of these things has a much easier time being able to correlate and introspect and cross-reference these types of environments and give you more clear understanding of where something went wrong. And when you can use all of those fun APIs that Metaflow provides and pipe them into a UI like Roman showed earlier, it gives data scientists a much easier way to understand what's happening in this flow and not what's happening on your container platform. And that's a really, really, really cool balance, independent of whether you're a data scientist or not. Now, it's not all problems to solve for Kubernetes. Kubernetes brings a lot of cool stuff to the table, notably being part of the open source ecosystem and also being as popular as it is means that there's an incredible amount of super mature, super powerful tooling for being able to get lots and lots and lots of detail about what's happening inside your containers, what's happening in an orchestration pipeline, what's happening in container logs, the health and well-being of our actual nodes. Are they auto-scaling? Are they not? It is incredible the amount of tooling that is out there in the open source ecosystem that Kubernetes supports and that supports Kubernetes. Now, with all of this maturity, there comes choice. Ask me how many choices there are. Oh, I'm so glad you asked. Thank you, sir. In a normal talk, I would actually bring up the CNCF landscape slide right here. I'm sure you've all seen it before. It's that slide that has hundreds of different logos, and it's broken down into multiple bits and says, these are the tools you use for this, and it's really confusing, and there's not a whole lot you can see. And I would also make a joke about how we were going to spend the next 2.5 to 3 hours going over each individual tool and how you as an operator can use it to make your clusters better. And I would do that all to make a point about the complexity of the ecosystem. But unfortunately, they told me we don't have the logo rights to most of those slides or to most of those platforms, so they didn't allow me to use the slide. But it seems a waste to waste the joke, right? So we should do the joke anyway, I'm sure. So I want everyone to use their imaginations. I want you all to think about that slide. Think about it. Don't know what it looks like? Let's say it looks a little something like that. Not too fast? Something like that. Kind of looks like that. So think, no, you know what? Imaginations aren't fun. I've changed my mind. I want everyone to open their laptops and go to landscape.cncf.io. I'll wait. It's actually a joke. Don't open your laptops. And for the record, it was blurred. I like my job. I don't want to get in trouble. But this is the slide. And the reality is this ecosystem, as amazing as it is, complexity doesn't help when the objective is to try and remove confusion from a specific end user like a data scientist. I love most of the tools that are in the CNCF landscape. I love them. I think they're incredible. But the practical reality is, we need to be prescriptive when we're talking about tuning something like Kubernetes to a very specific use case. And we've made some progress on that. So for those who have done a little bit of research into Metaflow or have been following along since 2019, I have to give a merciless plug to our talk last year. We did talk a little bit about something that's up on the Metaflow Tools GitHub. Metaflow Tools has a CloudFormation template, as Roman mentioned. That CloudFormation template is designed to deploy out all the AWS infrastructure that supported at the time the pre-Kubernetes version of Metaflow. And even that isn't super simple. That's not even the Kubernetes CNCF ecosystem. Even that has its own complexity. I talk a little bit about what that CloudFormation template does, and it's cool, but it's still a lot of stuff. The nice thing about it was that it existed within the context of the AWS ecosystem, so we didn't have to worry about things like IAM permissions, and we had an easy language to be able to code all of those deployment methodologies against. Everything that we needed to deploy, for the most part, supported CloudFormation as an infrastructure as code language. And it was an incredible achievement. I think at this point it's 1,500 lines. It has a bunch of community support. People have added stuff to it. It's a really interesting piece of code, albeit getting a little bit large at this point. We're probably gonna have to break it into bits. But this changes a bit whenever we talk about deployment on Kubernetes. Running a Metaflow infrastructure on Kubernetes and using it as a compute layer is relatively easy. Our developers don't and shouldn't care about this. It works. You can go deploy it now, and if you have Kubernetes environments, you can use it. I think it gets more complicated when we talk about what does Metaflow need inside of Kubernetes in order to facilitate its own existence. What can benefit Metaflow that has to exist in the cluster, and who is responsible for installing and managing that? And I think to some extent that's still an open question. Let's explore why that is. So if we take that CloudFormation template that we talked about earlier, or a variation of it, and we talk about what it deploys, right? Metaflow uses S3 to store artifacts. It uses Batch as a compute layer. It might use Aurora or RDS to store metadata for a metadata service that holds historical information about flow runs. This is all great. We can do this in CloudFormation. We can even deploy out EKS with CloudFormation. Hooray, we should be happy, right? But we've created this really, really bizarre little language barrier in the middle. It's kind of what I call the language barrier. Because CloudFormation is one type of language, but Kubernetes, as we talked about earlier, has an entirely different type of API that's declarative in nature. There are lots of tools that you can use as an operator to deploy out what you need inside of EKS or Kubernetes in general, for example. But what if Metaflow requires something like Postgres or Minio or Argo workflows or something along those lines? How do we get that in there? And I think that's where it gets really, really tricky. Like, there are tools that do this. You can use Helm charts, you can use manifest installations, but the practical reality is we need to be opinionated here, because Kubernetes at a specific version supports a certain API type, and all of these individual bits and pieces that we might use for Metaflow also have their own versions, which depend on certain underlying Kubernetes APIs. So there's this whole fascinating debate about what do you bootstrap into the cluster? How do you update it? Do you update it? And who's responsible for the long-term management of that infrastructure? Do we expect it to exist, or do we want to create an amazing deployment experience for end users who want to use Metaflow on Kubernetes? And the reality is, we want the latter. But that's still something that we have to be very opinionated on, because when you have an ecosystem that's that flexible, how do you make sure you're not painting people into a corner? Or you're not giving them too much flexibility where it's no longer easy for them to deploy these ecosystems out to their data scientists. Frankly, to be direct, this is a problem with the Kubernetes ecosystem in general. It's like the world's worst kept secret, that this like flexibility and version management operational primitive is one of the things that makes Kubernetes have a reputation as being hard to manage. The reality is, an empty Kubernetes cluster really isn't. It's a bunch of this other stuff and how you keep it incrementing forward that becomes tricky. And that becomes doubly important when you're talking about applying this to an ecosystem that could not care less about the underlying infrastructure like data scientists. So, fortunately, it's not as hard as it used to be to solve these problems. That deployment chicken and egg problem is something that you can easily solve with some of this stuff. We as AWS are baking an open source project called CDK that's still being toyed around with, that applies some of our cool infrastructure as code paradigms that we use in CDK and allows you to use them on Kubernetes. Terraform also has a Kubernetes provider, which means you can bootstrap some stuff in AWS and then in turn use the bootstrap services that come up for Kubernetes as a provider so you can deploy stuff into it. We can solve problems like that. There's lots of interesting infrastructure as code stuff that you can do to kind of sort of fix this. And then the GitOps world, like Weaveworks Flux, also adds an interesting paradigm to this because it gives us ways to sync internal cluster configurations to external Git repositories. So that means that you can generate some interesting code manifests that in turn your Kubernetes clusters will respect and sync against. So there are a lot of cool tools to solve this problem, but again, there's this kind of parallelization of choice in terms of the way you want to do it. We need to be prescriptive. And I think Netflix and Outer Bounds and AWS and probably everybody in this room has some opinions about the way they want to do it, but I think we want to be careful about the way we approach it. We want it to be something that matches customer and data scientist use cases. So I'm going to throw out some considerations, and I'm not going to call these unanswered questions because I think we have opinions on them, but I will say they're questions that we enjoy exploring. So if you as a community have feedback about these things, we're always interested in hearing your use cases, your pain points, what we could do better, both as AWS and as Metaflow and an open source community. So these are just a few. So the original version of Metaflow, the first open source version of Metaflow, and the version to date has traditionally used S3 as its artifact store. And that works incredibly, incredibly well. It's scalable, it's fast, it does exactly what it needs to do for those types of artifacts. But Kubernetes opens the door of an environment that might not be in AWS, or an environment that might be internet restricted. So the question becomes, do we still use S3, or do we look at what a S3 compatible storage optimization inside of the cluster might look like? Do we deploy that, or do we expect the customer to deploy that? Who's responsible for managing that ongoing life cycle of that storage solution? There are plenty of them out there. There's GlusterFS, there's Minio, there are a bunch of S3 compatible storage solutions. But then immediately you go down the path of wondering, like, what about other potential storage solutions that have specialty requirements for caching tiers or super low latency? If you're going to have a Kubernetes cluster on premises, you probably have latency concerns. So what are you going to do about storage in that particular case? It opens up this Pandora's box of questions. As Roman was talking about earlier, one of the sequencing and orchestration or DAG scheduling tools that Metaflow supports now is step functions. Step functions supports EKS. But again, if we go down the path of open source tooling and we try to take into account the types of environments customers might have, people use Apache Airflow. People use Argo workflows. What types of systems should we take into account for orchestrating these pipelines for long-running production executions? And then there's that question again, who installs and deploys it? How do we manage versioning? And how do we ensure that Metaflow, as an SDK, has the right versions working on the back end to do what it needs to do? These are huge questions, which, again, we have opinions about the answer on, but are always looking for more feedback. And then probably the nastiest of them all, authentication. Authentication is a huge spider web of terrifying questions and implications. Security is such a big deal, and whenever you're using Metaflow with AWS Batch and you're using it with the CloudFormation template as it stands, everything has an IAM role, everything has predefined IAM policies. I personally have spent huge amounts of time trying to ensure that they were as secure as possible and did everything they needed to do. It's easy to authenticate something like a batch execution to S3. They're both native AWS constructs. But what about a Kubernetes pod? The answer is easy with something like EKS. We have IAM roles for service accounts, which lets a pod assume a service account identity through IAM in exactly the same way that a batch execution could. But what if it's not EKS? What if it's an on-premises system? And the same thing applies to user authentication. Whenever we generate the CloudFormation template as it is today, we generate a user that has restricted permission only to make API calls against the specific AWS primitives that they need in order to execute Metaflow flows. So how do you do that in a world where you're working with stuff inside of a cluster that you may not necessarily have cross-correlated effectively? Is it our responsibility as an SDK, or is it the operator's responsibility? And I think the reality lies somewhere in the middle, but I think what we want to know is, how much do you want someone else driving your Kubernetes infrastructure if you are choosing to use Kubernetes? I think it's an open question. The short answer to this is use EKS right now. This is super simple. IAM roles for service accounts give you that identity necessary in order to work with S3. You don't have to worry about like cross-platform challenges. Like, most of these problems are solved if we talk about EKS, because EKS is designed to be a system that works with all of the native AWS primitives as tightly as possible. The longer answer is still use EKS, but we want to know what your use cases are. We want to understand your pain points as a community, If this talk has been interesting to you and you feel like Metaflow is worth exploring, I think we'd all like to understand what we can do better and what these platforms, be they AWS or Metaflow, can do to work better with your ecosystems. And how can you do that, you might ask? And I'm happy to tell you that we have resources to conclude the talk with. Come and join us on Slack. You can find us on slack.outerbounds.co. Roman is there. I am there. A bunch of other friendly friends from the community are there who have lots of opinions about the way these things work and really, really, really want to make new friends. We have documentation and tutorials on docs.metaflow.org. We have sandboxes that you can spin up so you can test production runs of Metaflow in the cloud without needing to spin it up on your own infrastructure. You can find those at metaflow.org/sandbox. And that, ladies and gentlemen, with 4 minutes to spare, so I didn't get the hook that I was promised if I ran over, is the end of our talk. Thank you very much. I am Rob. This was Roman. If you have any feedback whatsoever for us, please complete the session survey. I will tell you that I will personally read every single piece of feedback that you provide. I will make Roman read every single piece of feedback. That is my promise to you. We have 4 minutes left. I think we can call the talk, but I'll stick around for the remainder of the time if anybody has questions. And Roman hasn't gone anywhere either. Thank you all so much for spending your evening with us. It actually means a huge amount.